The most simple series is a telescoping series, but let's first talk about telescoping sums. A telescoping sum is of that form that we have terms ak with a plus sign, and at some point we will have them with a minus sign. For example, this sum will be something like this. And now most of the terms will cancel out. So the sum of this series is just the first term minus the last term. If the limit of the general term is 0, then by letting n to go infinity, we would obtain that the telescoping sum would converge to A1. So for telescoping series we have this quite simple formula. We can consider this series by checking its general term. We can see that the series is telescoping. So the sum of the series is the first term in the series. This one with n equal to 1. So the sum of the series is 1. Let's obtain a formula for the geometric sum. Well, if r is not equal to 1, we can both divide and multiply with 1 minus r. Now we see that the general term of the series is r to power k minus r to power k plus 1. So our sum is telescoping. I wanted to have a 0 here as the first index, so let's do that. Now we obtain our formula. Let's calculate this geometric sum. We are summing powers of 2. By the formula for the geometric sum, we will obtain the sum to be 127. I usually write the letter R in this form, so these are actually the same letter. Well, if we would have that our r to power n plus 1 would go to 0, that means the absolute value of r would be less than 1, then we would obtain that our geometric sum would approach this value. So for these values of r, we can get the formula of the geometric series. If the absolute value of r is less than 1, then r to power n will go to 0, and we obtain the formula for the geometric sum, for the geometric series. Let's consider this series. We find the value of a and the value of r, and r seems to be having absolute value less than 1. We use our formula, and now the minus signs will cancel, and we can simplify by multiplying the numerator and the denominator by 3, and what we will get then that the sum is equal to 1/4. How about this geometric series? Well, now our constant A is 13 and our R is 7. Well, now the absolute value of R is not less than 1. So the series does not converge. Now all the terms in the series are positive and the partial sums seem to form an increasing sequence. So it's also fine to say that the sum of this series is infinite. So the series diverges to infinity. Let's also prove a result that if a series converges, then its general term goes to 0. So now the partial sums of the series will converge to a real number, and this real number is denoted by this expression here. We can express the an as a difference of two partial sums. Now both of these terms here will converge to s, so that means that an will converge to s minus s, which is equal to 0. So our theorem is proved. If we have two converging series and we take their general terms and form a new series as the sum of the general terms, then we will have a simple formula for the sum of the new series. If we have a converging series, then we can put a constant inside the series or take it out from the series. The proof of these facts relies on the thing that the formulas are true for partial sums. Now, for these partial sums, we can let the upper bound to go to infinity, and we will obtain our formula. And also here, when we take the limit, capital N goes to infinity, we will obtain our formula.